In the last class, we were discussing about the tokens, the character set. We discussed about the character set used in C programming. And then we discussed about the different types of tokens. There are 6 different types of tokens available in C program: keywords, identifiers, etc., etc. And we discussed a bit about all those types and all those types of tokens, and some details about the identifiers. Now, in this class, what we will be discussing mostly is about the variables. If possible, it will be variables and data types. Otherwise, before starting this variables, the types of variables and the type of data types, actually, the different kinds of data types that is available in C program. Let's see a simple C program. Why? Because using this C program, you will understand a bit more about how the C programming is done. In the previous example that we discussed, that was we were displaying the welcome to C on the screen. In that one, we used 2 functions. One was the main function, which should be present in all the C programs, and the other function was printf function. Printf function is used in order to display some message on the screen that we housing, and how that printf should be written, that also we housing. So now in this case, in this class, first we will see a simple C program. Okay, this is the starting of the C program. This is not the complete C program, because if I included the complete C program in a single slide, it would not have been visible. The total thing may not have been visible to all of you. So that's so I split that into 3, that C program into 3, and inserted in 3 different slides. So this is the first part of that C program. The first line, as in all cases, the first line is a comment. You know that how a comment is written, that is a slash as well as star, then ending with a star as well as slash. So the first 2 lines are comments, that is programmed to calculate the sum of 2 integers. So it gives you an idea about what this particular program represents. So it takes in 2 integers and it calculates the sum of that particular 2 integers, that is written, or that is input by the user. So then this program is known as the addition program. That is, we are adding 2 integers together. Then the preprocessor directive #include stdio.h, that we know that what this particular line means. That is, the stdio.h, the standard input output header file, is included into our program. So that is what this #include stdio.h means. So we included the standard header file, that is standard input output header file, that is stdio.h, is included into our program. This is a preprocessor directive. This particular line, this line that is given in the green color, it is a preprocessor directive. That is, before the compiling starts, the preprocessor has to include this particular file into our program. Then a blank line. Obviously, in C programming, you can leave as many blank lines as you desire, and which is good for reading your program. So unless the blank spaces is not in double quotes, it won't be counted. So how many blank spaces you leave doesn't count in the case of simple C programs. I mean, in the case of C programs, unless it is within double quotes. If it is within double quotes, it will count. Otherwise, in most of the cases, it will be counted only as a single white space. Then in the next line, it is another comment, that is the function main begins program execution. So this particular line is written in order to denote that we are starting with a function, and in this case, that particular function is main. Main is the function that is that should be present in all the C program. So from this line onwards, from the next line onwards, the main begins. The function main begins. So the function main starts here. Int main void. You know what this particular int means. It says that there is some return value will be given. Some value is returned from this particular main function, and that particular a returned value will be of type integer. So this int means integer. So integer type will be returned by this main function. So in the previous example also, we have a statement known as statement return 0 was at the end of the program. So that particular statement says that S0, the value 0 is returned if the program executed well. So that is 0 is an integer, that is why it is int. Then main, this is the function name main. Then in all the functions there should be parentheses, a set of parentheses, a pair of parentheses should be there. So and within that parentheses, in this case, the main is in the case of main it is given as void. Void means nothing. You can leave it blank also, no problem. If the function doesn't have any parameters, that is parameters are the values that is passed into that particular function. That is, the function has to process this particular value. If a particular function has to process a particular value that is fed into that function from outside. So in that case, in this case, void, that is nothing is passed into the main function. So that is this int main void that we already know. Now the braces starts, the curly braces starts. Then this indicates that the function main, the body of the function main starts from here. The body, the statements that is important for the function main starts from this particular point onwards, this line onwards. So the first line, in the previous example, it was only a single statement, that is printf was there. But in this particular example, it is there are 3 lines starting with int, int, integer 1. So then after that there is a semicolon. In C programming, this is a must. This semicolon is a must. At the end of each line, each statement, each valid statement of the C program, you should put a semicolon. At the end of the comments, it is not necessary. It is not required. At the end of the comments, it is not required. But all the statements that should be executed by the compiler, or that should be executed by the program, there should be a semicolon put at the end of that particular statement, that particular line. So int integer 1, then semicolon. So this means that this int means it is integer. It represents integer. This is an integer, and integer 1. Integer 1 is the variable name. A variable name is declared. A variable name is declared. That is, integer 1 is declared, and the type of that particular variable is int. That is this integer 1. It can be x, y, z, or a, b, c, d, whatever value. That can be a name for a variable. So in this case, we give the name for the integer, the name for that particular value as integer 1. So integer 1 is of type int. That is, this particular variable can hold only values of type integer. No floating point values can be stored by this particular, can be held by this particular variable. That is this integer 1. This particular statement, this type of statement is known as the variable declaration. We will see details of variable declaration in the coming lectures. So for the time being, you just understand that a variable is declared like this, int integer 1. Then this is the first number to be input by the user. So that is this particular integer 1. It will store the first number that is to be input by the user, which is used to calculate the sum. So then the second line, int integer 2. So it is the second number to be input by the user. That is, the integer 2 will be the variable name for the second number. Then int sum. Sum is the variable that will hold the sum of integer 1 as well as integer 2. Whatever value we enter as integer 1 and integer 2 are added together, and that value is stored in sum. So that is int sum. So there are 3 different variables declared here. That is integer 1, integer 2, and sum. Out of these 3, for integer 1 as well as integer 2, we have to enter values. The user has to enter the values. Then the integer 1 as well as integer 2 will hold those 2 values. And then what the program does is those two values are added together and it is stored in the sum. And then finally that sum will be displayed. So now we move on to the next line. So the next line of the program is printf enter first string /n. So you know what is printf, it is a function, and in this case, see, within this brackets or within this parenthesis, it is written as, within the double quotes, it is written as enter first integer /n. In the previous example that we have seen, the first C program that we have seen, within this double quotes, it was welcome to C. So it was printf, then welcome to C. In that case, that welcome to C was displayed on the screen. Likewise, in this case, in this particular line will display this enter first integer, that particular message on the screen. So see, you note that the semicolon, this particular line also terminates with a semicolon in all the lines, all the statements that should be executed should be terminated with a semicolon in the case of C program. So this particular line, that is enter first integer, will be displayed on the screen. So this particular character, that is /n, we have seen that this particular character represents a new line character. That is, the cursor will be taken to the next line. So after this enter first integer is displayed, the cursor will be blinking in the next line. So that is the /n. Then this is written as prompt. That is, prompt is nothing but it is prompting. The computer is prompting to us to do something. The computer is prompting to us to do something. Actually, it displays a specific message, that is enter the first integer. So that is the first function that we have seen. The first function that we have seen is main. That is the function that is required for all the programs. And the second function, actually, the second function or the first function that is taken from the header file. The first function that is taken from the header file is printf. So this printf is defined inside the header file. And that is, in order to use this printf, we have to include the header file stdio.h in our program. So the next line is scanf. This scanf, scanf is another function like printf, which is defined inside the stdio.h file. So scanf is another function, and it has actually two different parameters. So two different parameters separated by a comma. This comma divides this two, the things that is on the left as well as on the right, as two separate entities. So there are two parameters. Two things are passed or two things are given to the function scanf. The scanf is also a function within the stdio.h file, and it has two different parameters. One is within double quotes a %d, and then this comma separates that particular parameter from the other one. So this is an ampersand integer 1. So these two parameters are necessary for a scanf function. So what the scanf function actually does is, it takes in or it reads values input by the user. That is, printf actually displays or output some message to the screen, and the scanf reads some value into the computer or into the program. So that is the standard IO, means that is standard input output. So scanf reads input from the standard input device. Normally it is the keyboard. The standard input device is normally the keyboard. So the scanf takes in value from the user or from the standard input, and the printf displays messages to the standard output. Normally the standard output device is the screen, so the monitor. So printf outputs the value and the scanf reads the value. So in this case, two separate parameters are required for scanf, and the first parameter, this within the double quotes, the %d symbol, this represents the format control string. The format control string actually denotes that what type of value will be read by this particular function. What type of value will be read by this particular function? So it can be percentage D, percentage S, percentage C, etc., etc. So there are, depending on this type, this is what type of data is read by this particular function. This percentage D symbol can change. It can percentage S, percentage C, etc., etc. So that we will study later. And this percentage D is actually a conversion specifier also. That is percentage D means a conversion specifier. The conversion specifier means whatever input we are giving to the standard input device, it is converted to this. Percentage D means it is converted to integer type. This percentage D means it is decimal integer. That is the integer is in terms of 10. That is decimal integer. So that is why it is percentage D. So whatever value we are entering, it will be converted to corresponding integer values. So that is what this particular percentage D means. So even if in this particular message or in this particular prompt, we are entering some, some floating point values, it will be taking only the integer part. The floating point part, that is whatever comes after that point, the decimal won't be taken. So that is the percentage D means. Then this ampersand integer 1. This ampersand actually denotes the address of this particular integer. The address of this particular integer means the integer is stored inside the memory, and each memory location has a particular address associated with it that we have seen in the first module. While we discussing about the computer systems, it was the memory. It is said that for each memory unit there is an address associated with it. So this ampersand integer 1 means this integer 1 is a variable, and ampersand denotes that a specific memory, the specific memory location in which this particular integer 1 is assigned, or the memory location that is assigned to this particular variable. So the details of that we will understand. You will understand later when we are studying about the pointers. Now just understand, or just remember that while reading something to this particular, to a particular variable, you have to put this ampersand symbol in front of it. Ampersand symbol in front of it. In most of the cases, in some cases you don't have to put the ampersand symbol also, but in most of the cases you have to put the ampersand symbol. The exceptions that also we will discuss later. So while reading some integer values, you have to put an ampersand symbol. So again, it is terminated with a semicolon. Then finally it is read an integer. That is the comment. That is, we are reading an integer. In this case, even if we are entering a decimal values, that is some floating point values, the system will, the program will read only the integer part of it. Then the second printf, that is enter the second integer, that is the prompt. Then scanf percentage D and integer 2, the ampersand integer 2. So that is the value is stored into the memory location assigned to integer 2 variable. So it reads an integer. Then what we does is we does the operation that is to be done. So integer 1 has got some value and integer 2 also has got some value. Then these two values are to be added together in order to assign it to sum. So sum is assigned with sum equal to integer 1 plus integer 2. So this statement, this integer 1 plus integer 2 adds the two values together, and then that particular value is assigned to sum, this particular variable. So sum is assigned with integer 1 and integer 2. Say, let's take integer 1 as 3 and integer 2 as we input it as 4. So in that case, 3 plus 4 will be 7, and sum will be assigned with, sum will be equal to 7. So then we assign the total to the sum, that is it. So this is the comment that is assign the total to the sum. Then finally what we have to do is we have to input this sum, we have to display the sum on the screen. We have to display the sum on the screen. So for displaying, the function that we are using is printf. So printf, then within the parenthesis, double quotes, we start with a double quote, then sum is percentage D slash n. So sum is okay, that is the message. Then here is a percentage d. This percentage d is almost the same as this percentage d. Both are the same. So this is the conversion specifier, that is the percentage d, as I said, is a conversion specifier or a format control string. This within double quotes, it is a format control string. Without that double quotes, it is a conversion specifier. So this percentage d means that the value is to be put here. The value that is to be displayed should be put here. That is percentage d means it is actually it can be termed as a placeholder also. It can be considered as a placeholder also. A placeholder is where a specific value is to be displayed. So sum is will be the value, I mean the message that is displayed, and then percentage d. In the place of this percentage d, whatever value that comes after the comma will be displayed. So here the value that is after the comma is sum. So in our case it will be 7 in our case. So sum is 7. So what it is displayed will be sum is 7. So that this message will be displayed. So this message will be displayed because this percentage d is replaced with the value of sum. Then there is a slash n. The slash n means it is taken to the next line. So that is this particular printf statement. So in this particular printf statement, in the previous printf statements here as well as here, the printf statements had only one parameter, that was the enter first integer as well as enter second integer was the only parameter that was passed into the printf statements or printf functions here. But here, if you see here, there is two different parameters there. So both separated by a comma. So the first statement is, first parameter is sum is percentage d slash n. Then the second parameter is this sum. This is the second parameter. So what in this case, if a second parameter is present as well as a percentage d, where a conversion specifier or a placeholder is present in the statement, so in that case, this particular value is replaced with this sum. So that is how the printf function works. Now, finally, we return the value 0. That is, it indicates that the program ended successfully. This return 0 is dependent on the int main void. So since we have given an int statement there, int value there, in the case of int main void, you have to give a return 0 also. Then finally, we end this function main with a semicolon, with a curly braces. So this is how this particular function is. Now let's see how this particular function works. So this is the same function that is that we have discussed. It is type written in developer C++. I commonly use developer C++ because it is easier. What I found is it is much easier to type the codes. Obviously, you can follow the other things also, other integrated development environments, that is IDEs like code blocks or anything else. Even IDEs for C programming in Android environment is also available. That also you can use, no problem. You don't have to follow this developer C++ in all the cases, but you can follow the the code blocks also. I am following with this one, but in our college, if you come to our college and do practical labs in our computer lab, also it is the developer C++ that is installed in our systems. So it is what I suggest is you install this developer C++ in your system also, in your system that is using in your home. So this is being compiled. In order to compile, you have to click on this one. So I compiled it without any error. There are no errors in this particular case. So the same program, no change. Now I am trying executing it. We are running it. So enter the first integer. So I am entering the first integer. Say it is 8. The first integer is 8. Then it is asking for the second integer. So see, the cursor is blinking here on the next line. It is because we have put a new line character at the end of this particular message in the second integer. Sorry, enter second integer. Now I put it as the second integer as say 3. So finally, what it displays is sum is 11. So 8 plus 3 is 11. So that is the program how it works. That is, it takes in the first integer, that is integer 1. 8 is taken as the integer 1, and the second integer is taken, that is the second 3 is taken as the second integer, and then sum is assigned with the values of the sum of the result from the addition of the first integer and the second integer. So that is 11. So that is assigned to sum. So the value that is displayed, or the result that is displayed, is sum is 11. So this is the addition program, the second program that we have discussed in our C programming class. Now we have seen the second program and some things about the variables how we have seen. So let's move, or let's study details about the various data types as well as variables, the variables and the different types of data types. So any doubts still here? Any doubts regarding this simple C program? Okay, I hope there is nothing, no message or no response from the students. So I hope there is no doubts from the students. Now let's move on to the variables and data types. We have seen that in the previous program, the integer 1 as well as integer 2 were the different variables that we used. Not the different variables, but the variable names. Integer 1 and integer 2 were the variable names that is used. Actually, the variable names are the identifiers. We have seen that out of the different types of tokens, identifier is a type of token, and out of these identifiers, variable name is a type of an identifier. So the variable names integer 1 as well as integer 2 falls in the category of identifiers. So variables, actually variables is a name that is given to a storage area that our programs can manipulate. So integer 1, when we declare a value, like when we say that integer 1, we store some memory, or we reserve some memory to store some specific values in that particular memory. And this particular name, the name integer 1 or whatever the variable name is being used, that name is a way to access that particular memory, the value assigned to that particular memory. So that is a variable as well as variable name. So a variable is a name that is given to a specific storage area, and that particular storage area should be accessed by your programs, and the values within that particular storage area should be manipulated by your program. It should be able to manipulate it by your program. So in each variable in C has actually the in C variables in C has three aspects. One is a specific type, that is what type this particular variable is, which determines the size and layout of the variable's memory. And depending on this particular type, this particular specification, that is what type of a variable is it, the size and type, layout of the memory is stored. That is how much memory should be stored, or how much memory should be reserved for that particular variable. That is decided depending upon the specific type. And one of the type is integer. We have seen that int variable type, integer 1. So that particular statement, in that one, the int was the specific type, the variable type. So then the range of values that can be stored within that particular memory, and depending on the specific type itself, that is this range of values is determined based on the specific type. Yes, example, the integer values can store value from this particular particular range to particular range only. Only values within that particular range can be stored by a variable of type integer. If it is a floating point, the decimal digits or decimal values can also be stored by that type of variable. And the third aspect of a variable is it has a set of operations that can be applied to that variable. If the variable is of type integer or floating point, that is any numerical type, the operations that is applied is the normal, what you say, the addition, subtraction, multiplication and division operations can be applied to that particular variable. But if that particular variable is of type character, in that case the addition may not be possible, because no character can be added to another character unless they are converted into ASCII codes. So it depends on the set of operations, again depends on the type of the variable. So each variable has a type, and depending on the type, the range of values is fixed, and the set of operations that is applicable to that particular type of variable is fixed. We have already seen that the names of the variable, that is the name of a variable, can be composed of letters, digits and underscore character. That we have already discussed in the case of the identifiers. In the case of identifiers, how the identifiers should be created, the names of the variables should be given, that we have already seen. That is, it consists of only letters, digits and underscore character. And it must begin with either a letter or an underscore. That also we have seen. Uppercase and lowercase letters are distinct because C is case sensitive. That is, we have already seen that total all these for different values are different. That is, depending on the capitalization, the uppercase and lowercase letters are distinct. So this one will be different from this one, and that will be different from this one, and that also will be different from this one. So depending on the capitalization, different names will be having different meanings. So a variable is an identifier that is used to represent a single data system, data item. Then once a data item is assigned to an identifier, then the item can be accessed later by referencing to that particular variable name. That is why we are using this variable name, because once a particular value is assigned, or particular data item, in the case of in our programs, we were assigning the value 8, the data item 8 was assigned to the identifier integer 1. So that particular value, that particular item was accessed later in that particular program by referring to that particular name itself, that is integer 1. In the case of when we were adding it, sum equal to integer 1 plus integer 2, we were actually referring to that particular variable. We were referring to that particular variable name, and using that particular variable name, we were referring to the value associated with that particular variable name. So a variable, that is name and type, has to be properly declared before it is used in a statement within a program. That is, in the case of C program, the variable has to be declared before it is being used inside a program. So in most of the cases, in the normal C compilers, you have to declare all the variables before the main statement, that is int main void statement. Before the function definition starts, the main function starts, you have to define all the variables that is being used. Sorry. Just after the int main, not before the int main. Just after the int main, you have to declare all the statements. Just after the that is like this: int main void. Then immediately after this one, you have to declare int integer 1, then integer 2, etc. Like this. That is just after the int main void, you have to declare all the variables. That is the declaration of the variables in between the statements of codes is not allowed in the case of C. In most type of C compilers, it is not available. That is, but in the C++, it is possible. That is, in C++, you can declare the variables in between your programs also. But in the case of C program, it is not permitted. So immediately after the function begins, that is the main function or whatever function, the function begins, you have to declare all the variables that is being used inside your program. In our example to that is in the simple program that we discussed today. In that case also it was like that. Just after this int main, we started with integer 1 and integer 2, etc. So that is that all the values, all the variables, not values, all the variables that is being used inside the program should be be declared before it is being used. So the value contained by a variable may change within the program, but the data type cannot. But like in the case of suppose I have declared a variable like index. So x is a variable. So initially x can be given a value, say it is an integer. So initially it was given a value 0. So after x, after some statements are executed, the value of x can be changed to 10. No problem. X can be changed to 10, but the type, it should be an integer. The changed value, the new value should also be an integer because it is already declared by a type as integer. It is a type of integer. The x can hold only values of type integer. So the value can change, but the data type cannot change. So it can be only 10. I mean, any integer value can be held by this particular variable x. No other value, like if I want to store a value like say 7.5, it is a floating point value. So it cannot be stored inside x. This will be wrong. This won't happen. If you assign a statement like this x equal to 7.5, x will be taking some other value. Maybe 7.5 is rounded off to 8. So that sort of things can happen. So x will hold only integer type value if it is declared as integer type. So a value contained by a variable may change within the program, but the data type cannot. So the data type of a particular variable will be the type that is used while declaring that particular variable. So we have seen a simple C program. Then we have seen something about the variables, variable names, and the data types. The details of the data types we will discuss in the next class.